My name is Julian Maczynski. I'm currently a PhD student at the Technical University of Munich. My main role is leading the development of the Feature Cloud platform, making sure that it runs stably and smoothly, and also, of course, that the privacy requirements are maintained. But in the end, it's, of course, a team effort.
Who are those other developers?
Those are also PhD students to a large part, but we also have two developers who are currently in Romania. They have expertise in the area of software and web development and bring a practical perspective to our academic project, which is a great addition.
How can machine learning advance biomedical research?
Machine learning, especially in bioinformatics, is widely used currently. This is because we have really large quantities of data in bioinformatics. So, for example, genomics data or gene expression data. And it is virtually impossible to process and analyze this data manually. Machine learning can help us to find out certain correlations, predict whether someone might be susceptible to a certain disease. We can do that completely automatically, and this is the great advantage of machine learning. We do not even need to understand the data ourselves, which we often do not, to be honest. Of course, these results, medical people need to look at that data and then see how they can make sense of this from a medical perspective, which is, of course, important when you want to base treatments on this.
What makes the Feature Cloud AI Store an all-in-one solution for federated machine learning?
When we want to use federated machine learning, which involves multiple partners, institutions, medical facilities who want to collectively use their data, then this is much more complicated. You cannot simply use an off-the-shelf machine learning algorithm and apply it to your data set, because you do not have a single data set. You have many data sets, really. And this, of course, involves many things, starting from organizing the collaboration, but also the execution of the algorithms themselves. We have many parts in the system that need to talk to each other, communicate with each other. And Feature Cloud tries to remove all these parts that all of these algorithms need. We also have a store with ready implemented federated applications. So in the end, all you need is the Feature Cloud system. You need to choose an app and run your project over the Feature Cloud platform, which is much simpler than having to set up everything from scratch.
What are the key demands that the Feature Cloud AI Store meets?
The three main areas in running such a federated project starts from development. Here, Feature Cloud can help because we have extensive tooling for developers and app templates and so on. It covers also distribution of these apps, so you need to somehow hand them over to people who want to use them, and the actual execution. Our apps are free of charge. You can browse these apps in our AI store, select those that are interesting for your application, simply choose them, make them part of your project, join together with other people, and collectively run these apps. We are also open to external developers. This AI store can be extended with other implementations, for which we have an open API, and also, of course, documentation to make it easy to develop such apps.
For people who are not out of IT, what's API?
API stands for Application Programming Interface and serves as an interface between two programs, essentially. So it's a language which makes it easy to extend an existing system.
On the website, you mentioned that each app acts like a server. Can you explain?
This might seem confusing at first because you would think that Feature Cloud is the server and the app is the client. This is really a technical term here. A server is the instance that answers a request, and the client is the one querying the server. It does not mean that the app is the bigger part in the system. It's normally a lightweight, smaller part. The reason why we implemented it that way is that we did not want to allow our apps to access the internet, to freely access our API, because this would be slightly less secure. Rather, the Feature Cloud controller, this is what's running locally at each institution, actively queries the app. So it's the other way around. So we decide when we want to fetch data from the apps and not the other way around.
What type of data does the Feature Cloud system actually process and where?
The Feature Cloud apps process the local patient data that resides at the hospitals. And this is the unproblematic part, because we can process the raw data where it already is. This does not reduce privacy or security. However, if we want to have a global model or global insight, we do need to share something. But what we share is not the individual patient data, but rather a high-level finding on that data, simply put. On this higher level, we can then merge all these aggregates to get a global aggregate, which is much better than each individual one. This general idea of federated learning already makes it much, much more secure and privacy aware than merging all the data and training on this data.
Can you give a step-by-step real-life example of how biomedical researchers may use the AI store?
We have a setting where we have multiple hospitals and each is collecting data. We will take, for example, genomics data from the patients, so basically the varying parts of their genome, we would measure that. If we have indications that there's a correlation between genetic variants and the risk of getting a certain disease, such as COPD, a lung disease. Once we have this data and the patients have given consent that it's okay for them to use that data for research purposes, we could now take Feature Cloud to conduct a study on this data. First, you would, of course, need to choose an app for that. So we could use a linear regression app here, which tries to find correlations between each individual base pair and whether this patient has COPD or not. Then those who want to participate in that study would collectively join a project on our Feature Cloud system. And one of these participants takes the lead hospital. They are responsible for inviting the other parties and organizing everything. The only prerequisite from a technical perspective is having the Feature Cloud system installed, and you're good to start the study. Once everyone has become part of the project, the lead hospital has had a final look. They can trigger the execution basically, and from there it's going more or less automatically. In the end, we get the same results. In this case, I can really say it's exactly the same results that we would have received if we had merged all the data before. In the end, the results are shared with all the participants and everyone can benefit from the insights gained from this. And the insights in this case would be which varying base pairs are related to this disease. And this is, of course, a good to know, because then you could say in advance whether a certain patient has a higher risk of getting this disease.
What types of federated apps does the AI store currently offer?
So we have the most popular machine learning algorithms in our store, such as neural networks, random forests, support vector machines. This is something that will ring a bell with people familiar with machine learning. They are simply being used widely for different kinds of applications, also suited for different types of data, imaging data, omics data, and so on. And we have some more targeted applications, such as time-to-event analysis, which you would use for a specific research question. In this case, how is the survival curve affected?
Which privacy-enhancing technique does the AI store require or enforce for new apps?
We really only enforce federated learning. This is the main privacy-enhancing technique that we support. And all other methods you would just implement in the app and then, of course, indicate that you have implemented them. That's why you can filter for them in the App Store. At this point, Feature Cloud encourages usage of these techniques. What we're planning to do is really integrate parts of these methods in the system itself. As of now, external developers would need to implement that. Of course, we offer templates that show how you can do that.
Who can be a user and how are site, coordinator, token, and workflow defined?
Everyone can create a user account in case you are a developer and want to develop an app, or if you want to use an app. In both cases, you would need a user account. A site really is the representation of a physical location where the data resides. You can also have multiple users, for example, managing a single site. When you want to execute a workflow, you have to have a site. For developers, this is not a requirement. The coordinator is responsible for creating the project in the first place, deciding which apps should be part of that project. Also, the project coordinator decides who will participate in this project. They would invite other participants with so-called tokens, which serve as entry ticket to the project. He will also finally start the execution of the project. The workflow is part of that project, nothing else than a sequence of apps that will be executed in the context of this project. The workflow could be reused in other projects.
Who can develop and contribute a new app to the AI store?
Technically, everyone can do that. Of course, if you want your app to really appear in the AI store, it would need to undergo a review process. This is necessary because we need to ensure that firstly, it is usable and not a frustrating experience to the user. And secondly, that it really fulfills all the claims and promises it makes, particularly in terms of privacy awareness. If a developer has already experience with machine learning, with conventional machine learning, they will find it easy. In case they already have implemented a federated algorithm, it should be pretty simple to turn this into a Feature Cloud app. All you would need to do is Dockerize it. So this Docker is a virtualization technique that we are using in Feature Cloud. If this is not already the case, because Docker is a quite popular technique, of course, you would need to implement the Feature Cloud API. And this API basically enforces just the federated concept. This also should be pretty simple because in case you already have a federated application, this is more or less already there. You just need to connect it.
Do you have a manual to help users and developers navigate the AI store?
We have a written documentation, a specification of the API, also tutorial videos and a manual basically where you can see which steps you need to follow. And I should also say that we do not impose any restriction on the technology you can use. You don't need to familiarize yourself with an entirely new technology, but you can stick with your favorite technology.
And who can developers contact if they get stuck, discover a bug, or if they have a question?
We're of course happy to help. So in case someone gets stuck, they can just write us an email. We will respond and assist.
How is a novel app tested before being certified by the Feature Cloud team?
We do support developers with testing by offering functionality that allows for automatic testing of the app and simulation of a federated workflow, because you do not want to set up a whole project with external parties and so on just to test your app. We have a simulator included in Feature Cloud that makes this much easier. And this really reduces development time. Once you have implemented the app and think it's finished and could be published, then it would be our turn to make sure that it really is usable, that it does not contain bugs. We will extensively test the app and also have a look at the code to see potential problems there. As long as it has not been certified by us, it will not be displayed by default. Normal users will not see them at first, but you can, of course, as the developer of the app, you can see it, use it, and test it.
Are there any technical limitations with regard to data processing capacity?
You could generally say that if it is possible for a machine to execute a conventional machine learning algorithm, it shouldn't be a problem to also execute its federated version, which means that if the data is simply too large to fit in the memory or to be used at all, then of course it would also not be possible to use it with Feature Cloud. There are no strict limitations in terms of data quantity or the algorithms that can be used. But of course, there is some overhead in terms of communication, because this is something that is new that you would normally not have with ordinary machine learning. And also a slight communication overhead can happen, especially if multiple iterations are required.
Does the federated approach also help to distribute the workload more evenly?
Yes, you're right. This is an optimization technique really to parallelize computation. It's true, federated machine learning is a type of distributed machine learning, but its main focus is not making it more efficient. But it can be a benefit in some cases because you really share the workload.
A philosophical question at the end. What's the difference between artificial intelligence and machine learning?
I would say that the general consensus is that artificial intelligence is the more general term referring to human-like intelligence. But of course, we are still far, far away from anything like human intelligence. So it describes basically all techniques that somehow go in that direction and resemble human intelligence. Which brings me to machine learning, which is a subgroup of statistical and mathematical methods and computational methods that are able to automatically make sense of various types of data. So you just provide them with data samples, for example, a label, and then these methods can learn how to predict that label from the data. And you don't tell them how to do that exactly, you just choose a machine learning method, and it will be able then to take new data samples and predict the label, which is of course very useful in terms of diagnostics and so on. It's impressive what we can do with these techniques, but in the end, it's still just mathematics, statistics, and algorithms.
Thank you very much.
You're welcome.